Thin film composite membrane starts with a base of polyester non-woven web, manufactured to exacting specifications. A microporous polysulfone layer, optimized for porosity, support, and strength, is cast onto the wet base. The actual reverse osmosis barrier layer is created by an interfacial polymerization reaction on the polysulfone substrate. This ultra-thin polyamide layer ultimately determines the membrane performance. The total thin film composite is about as thick as a sheet of paper, while the membrane barrier layer itself is about 1/500th the thickness of a human hair and flows out of the element. We begin with a product water tube, acting as the permeate collector. Sheets of the permeate carrier are welded to the product water tube. The number of sheets is preset depending on the specific element design. Membrane sheets are folded, barrier sides facing, and feed spacer material is inserted. A bead of glue is precisely applied around the edges of the back side of the membrane sheet. The folded leaf is mechanically inserted between permeate carrier sheets. Successive membrane leaves are assembled and inserted between permeate channels, with glue lines between adjacent leaves, forming a three-sided envelope enclosing the permeate carrier. Automated fabrication allows more shorter leaves to be assembled in an 8-inch element compared to fewer longer leaves with manual assembly. During operation, pressurized feed water enters the element scroll through the feed spacer and travels across the surface of the membrane sheet. Water permeates through the membrane into the sealed leaf envelope and flows along the permeate carrier in a spiral direction toward the product water tube. There it is collected and flows out of the element.